Okay, so let's try another one. We have here the integral of x squared times sine of x dx. Okay, so I'm gonna let this be my u, I let this be my dv. So my u is x squared, so my du is gonna be 2x dx. My dv is sine of x dx. So then my v is probably going to be negative cosine of x because that's the integral of sine. So now I have found my ingredients. Let me just put that all together in a formula. So that's going to be u times v. So that's going to be negative x squared cosine x plus the integral of, let's see, v du. So that's going to be v du, so that's going to be negative cosine, oh wait, sorry. Wait. This should be minus, by the way. So that's going to be minus the integral of negative cosine of x times 2x dx. And because I actually have the minus twice here, so I'm just going to change that to a plus. So I still have, I'm still running into an integral that's not so easy. I have now the integral of cosine of x to x dx. Now then, am I on the right track? It's probably so because I reduced from x squared sine of x to 2x times cosine of x. So somehow I reduced the coefficient, I mean the degree of x by 1. So hopefully if I do it again, that might just work. So I'm gonna do the integration by part again. I'm gonna once again let my u be 2x and my dv is gonna be cosine of x dx. And then, so my du is gonna be just 2dx and my v is gonna be just sine of x. So just this second part is gonna equal u times v, which is let me see. So just this box, by the way. So that thing is gonna be 2x sine of x minus the integral of v du. So that's gonna be sine x times 2x. So that's gonna be sine x times 2 dx. Oh, that's a good news because I can find the integral. So that's gonna be 2x sine of x. The integral of sine is going to be negative cosine. The negative cancel out, so I get plus cosine of x plus a constant. So I put everything together. So that means the whole thing. I'm gonna write. I want to write somewhere. So the whole thing is going to equal negative x squared cosine of x plus that chunk, which is going to be 2x sine x plus 2 cosine of x plus a constant. So sometimes it is actually necessary that you actually use the integration by part more than once. So in this case, I do it once and I do it twice, and that's how I came down to this final answer. Now, just once again, a few words of warning. When you try to do the integration by part a second time, if you use a wrong choice of u and v, you'll actually end up getting back to the same integral. So integration by part sometimes can be a little tricky. You will see that when I get later today.